In this video, we're going to understand the effect of sizing on expected performance. So we're going to use a game to demonstrate this. This game will be a coin flip game. We're going to flip a coin, and this coin is a biased coin. So instead of having 50% chance of landing on heads and 50% chance of landing on tails, we're going to let it have 55% chance on landing on heads and 45% chance on tails. Before we start the game, let's look at some definitions. Sizing, as we mentioned before, is the amount to bet on each trade. Let's start the game. Here is how we read this sheet. We have a total of 500 trials. This means we're going to flip the coins 500 times. To decide if heads or tails win, we have a result column D, and this result column is created using a random number generator that is based on a uniform distribution. Whenever the result is above 0.45, heads wins. Otherwise, tails wins. And this is our equity. We're going to start the game with $1,000, and whenever we win, we will make this amount, 30%. Whenever we lose, we will lose 30% as well. So it's a 1-to-1 risk to reward ratio. All the inputs in blue can be adjusted. The outputs are here. First, we have the number of times heads wins out of 500, number of times the tails win, and our final equity, our P&L in percentage form, and the number of trades to ruin. This means how many trades we took for us to hit rock bottom. Let us visualize this for a moment. If the chance of heads is 55% and the chance of tails is 45%, and we are always betting on heads to win, in the long run, our net P&L should be positive. So let's test out our theory. Let's say that now instead of 30%, I am risking 1% per trade. Let me run a few iterations by refreshing the sheet. All of our results netted positive payoff. This is consistent with our theory that we should be making positive returns in the long run, playing a game where we have an edge. Let's try changing our risk per trade to 2%. Run a few iterations. Similarly, our results are consistent with our theory. But what if I risk too much? I risk 30% per trade. Let me run a few iterations. When we risk 30% per trade, our performance becomes horrible. Take a moment to think why is that so. To understand why overbetting will cause us to destroy a positive expected payout strategy in the long run, let's adjust our equity risk per trade to 50%. We know in this game, out of 20 flips, 12 will be profitable, 8 will be non-profitable. Let's say we are unlucky. In the first 20 flips, the first 8 are tails. So we are going to lose on the first 8. Let's see what our equity will become after 8 losing flips. Using this equation, I can see what is our end result after 8 losing trades. We will be left with $3.90. With $3.90, we have to make back 250 times of our capital in order to reach our original equity of $1,000. That is a near impossible task, and for sure, this strategy is ruined. What if we are only risking 2% per trade and we have 8 consecutive losing trades? we will be left with $850. With $850, this is more than enough for us to make back the amount we lost and much more. Let's see this effect from another point of view. We know that when we lose 50% of our trade, we need to make back 100% to get back to our original capital. Because if we have $1,000 and we lose 50%, we'll be left with $500, and we need to make back 100% of that to reach $1,000 again. To illustrate that phenomenon, I've created this equity chart. These are the trials. On the first trade, we win. Second trade, we lose. Third trade, we win. Fourth trade, we lose. And this goes on in the alternate manner. Our sizing will be 50% on a 1-to-1 risk to reward ratio. When we win 50%. When we lose 50%. Look at this equity chart. Even though we win equal number of times as we lose, and our risk to reward is 1-to-1, our equity will drain off in the long run because of the unequal loss and gains phenomenon. Even if I put my sizing to a comfortable 2%, net, there will be a downward drift in our equity. The conclusion to this video: a good sizing methodology cannot make a negative expected payout strategy into a positive one, but a bad sizing strategy can destroy a positive expected payout strategy. In the next video, we're going to learn more about how this sizing theory can be applied to our trading. I will also attach this Excel sheet so you can play with the figures and develop better understanding of sizing theory.